Hi everyone. So you have now done your final homework assignment and we're moving into the final project. Basically, I have this set up like a series of homework assignments. You get a little bit more time to do them because they're a little bit more integrative of everything that we've been doing. So what I'm going to do today is go over the overview for the whole final. We have not learned how to do everything you have to do in here yet. So you're going to start with a piece that you do know how to do. And then over the coming weeks, I'll be teaching you some of the other pieces. So we're doing a UFO final because I think it's more interesting than working with other data. So we're going to be using something called the National UFO Reporting Database. This is a website that still gets updated that has reports of people claiming to have seen UFOs. So you can sort in a bunch of different ways. And I recommend that you take 15 or 20 minutes to just kind of explore this website to get a sense of the data. But we're going to go in and look at index by event date. And you can see that this is organized by month, including, I'm making this, you can see on March 22nd, and we've got reports from March in here. So it's really actively updated. You can see how many reports there are per month. And then if you click on a month, and you can see I've got a version in the background there. This is going to show you a bunch of different reports in columns with a bunch of data for each one. And if you click on the date and timestamp, you get this additional report of what was seen. So in this case, we have a mysterious light, strange, loud, short cannon noises that were eerie, a bunch of details about this, 2.5 hours in Turner Falls, Massachusetts. Here's when it happened. Here's when it was reported and posted. And then if we go back, you can scroll down and see all of the things. This should look familiar in structure to the turnstile data that we looked at, where you have a page here that has a whole bunch of links that go to pages that actually have data. The one main difference is that this is also a formatted HTML page. It's not a comma-separated page. And so what you're going to have to do is to extract the data from this database. That's part one of the final. So you'll come to this page. You'll extract all of the URLs, which is something that we did in the examples in class. That will take you to the individual month pages. And then here, instead of just working with a comma-separated file, you're also going to have to think hard about how do you scrape the HTML from this page. Here's a couple things that might be helpful. First is that you want to look at the HTML source for this. And again, you can do that with Control or Command U or do View Source. The nice thing is that this is super well formatted. So we have a bunch of TD tags. Those TD tags always correspond to this report data. It is always formatted in this way. So they're grouped into groups of, let's see, 1, 2, 3, 4, 5, 6, 7. So there's 7 TDs. Those are cells in the table. And it's always, the first one is always the date and time. The second one is always the city. The third one's always the state, and so on. And so if you are to loop through this, say you load up this file, you use Beautiful Soup to pull out all of the TDs, assuming you filter out any ones that may be up at the top, essentially you're just going to go index 0 will be the date and time. 1 will be the city, 2 will be the state, 3 will be the type, 4 will be the duration, 5 will be the report, 6 will be the report date. And then you can start that index again, or however you want to do it, but then you've got another group of 7. And so it'll require a little bit of thinking, but absolutely this is within your skill set to have an index and go from that index up to look at 7 cells, increment your index, and then go up another 7, and so on to extract this data. Your goal, when you're done with this, is to output a file that is going to have your city and state followed by the number of incidents that occurred there. So you don't really have to extract a lot of data from this file. Each row basically counts as an incident. So you need to extract the city and state, and then you want to keep a running total of how often that city and state had a report. So we don't care about the duration or the type or anything for this first stage. Just pull out the city and state, And then every time it appears, you're going to increment that. So you need to think about what's the right data structure to use. You could do this with an object, you could do it with a dictionary, but the important thing is that if there are 5 reports, and these numbers I just made up, these are not accurate. If there's 5 reports for Chicago, then you want to have those all added together. And you should create an output file that has the city, comma, state, and then a tab, and then the number of incidents that were reported there. So it should be straightforward because you do have city and state as individual columns here. So you can reliably put those together. There's not going to be states formatted in the wrong way. Now somebody's not going to have like just the city and not the state. So you know you have city and state, you want to put those together and then create a running total of how many reports there are. Now, you cannot just hit the index at this database over and over again. So let's go back here just so we can see this. So here we're at the National UFO Reporting Center website, nufroc.org. You don't want to be making a bunch of calls to this as you're testing your code. That's rude. They're going to block you. They're maybe going to block the whole class. I'm going to get really mad. You're going to fail this part of the assignment. It's like literally in the assignment that you're not allowed to do that. But obviously you have to test your code and debug it. So what I've done for you here is provided 3 links. You can see that these are just on my computer science website, and you can hit these as many times as you want. You can make thousands of calls to these files. That's fine. So the first one is basically just my version of the monthly, let's see if we can get this here. Sorry for that delay. Okay, so I'm just replicating the monthly reports. So you can see this is the actual NFO Reporting Center website. This is my website. I just copied and pasted their HTML, so all of the formatting is the same. If your code works on my website, it will work on their website. I have cut this down, so I've only got a couple months of data linked because basically you're just going to be looping through this, right? You're going to use Beautiful Soup to pull out all of the links, all of the A tags like we did in our example, and loop through them, follow those links, and extract the data. So you can test that with just 2, and you don't have to test it on all of them. These 2 link to pages. Again, I just copied and pasted the URL. You can see that this is hosted on my website. So both of these 2 months that are linked here, you can hit those pages as many times as you want because they're on my CS website. And they are processed exactly the same way as you'll process them on the actual website. So if your code can read my 2 pages, your code can read their pages. The only difference is that if we look at the source of my code, it's linking to pages on the CS domain. Theirs is going to link to pages on their own domain, but that shouldn't cause you any trouble. You should just extract the links, follow them, and then process the format of the monthly pages. So please, please do all of your testing on my pages, and only once they fully work on my pages should you run them on the actual UFO Reporting Center website. Basically, you should run your code 1 time where it's hitting the UFO reporting website. You should not be debugging on that site. You shouldn't be doing anything on that site until you are 100% sure your code works, because we don't want hundreds of students bombarding them with requests and screwing up their website or costing them more money. So please test everything on my version of the site first. Okay, so that, of course, is linked to you here in part 1 of this. So these are the websites you can test on. Once that works, then hit the big database, and so you'll have a huge file that you're going to output that will have city, states, and total number of observations for each of those places. What you have to turn in for this is a Python script. Note that there's a pretty strict naming convention here. I want it to match that. I should be able to run this just by typing Python space that file name. So I shouldn't have to put in any other information. It should run fine. You should output a file called whatever your last name is, underscore your first name, underscore cities.txt. You need this because otherwise all of your code just overwrites. If everybody calls it cities.txt, you overwrite each other's files. So make sure you use this name formatting. And it should have one city-state with the corresponding count. So Chicago, Illinois should only appear on there one time with its count. Um, in addition, to make sure that you're not screwing up the UFO Reporting Center website, you must include a sleep function of at least 5 seconds between every page access. So in the code that we wrote, that I have here, I have time.sleep of 1. You need to have time.sleep of 5 between every single time you do requests.get or whatever other script you're using. So it will take a long time for that code to run. Once it's working and you know it's working because you tested it on my pages, let it run overnight with those 5-second delays, and you won't screw anything up. I will not give you credit for part 1 if you leave off that sleep, because I will not have my students abusing their website. So pay attention to that. This is absolutely required to get credit for this part. Okay, so for part 2, you're going to basically take the file that you had in part 1, and you're going to convert your city and state names into latitudes and longitudes. So for this, you're going to use the Open Maps API. When you're watching this video for the first time, we will not have covered that, but we're going to start covering it pretty soon. So you will have gone through this process of using this API already. There are instructions here at this link to show you how you can take a city name with a state and then convert that into latitude, longitude coordinates. So basically what you're going to do is write a script. It's going to open up the file that you created in part 1, the last name, first name, cities.txt. It's going to go through, it's going to take each city-state name, run it through the API, get the latitude and longitude, and then create a new file that looks exactly the same, but instead of the city-state name, it has the coordinates instead. So you're going to turn in your script, same naming convention, last name, first name, final 2.py, that I can run just by doing Python and then the file name. You should open up your file with exactly the same name as what you turned in. That's because we're going to test this, and so we're going to have a file called last name, first name, cities.txt. We're not going to have it if you call it something else, so you need to make sure you open a file with that name. From the current directory, don't put a C:\/ or a /user/ whatever. Just open the file name by its name, because we don't have the same computer as you, and so it won't work if you have a full file path in there. You should output a file called last name, first name, latlon.txt. Make sure you name this correctly, because we're going to be testing with it going forward. And that output file should look just like this, but instead of the city-state, it'll have a latitude and longitude. For part 3, you're going to take everything that we've been leading up to. You're going to use that latitude, longitude file with your numbers to create a heat map. Okay, so I have edited the assignment a little bit since I first recorded this, because Google has changed their API for maps, so you have to pay for it. So if you were looking at what was typed in that assignment in the video, I have updated it, and it'll be updated with what you see on Canvas. So you may have seen mention of Google Maps if you were looking hard at the text in the earlier part of this video, but we're actually updating that. So for the heat maps, you're still going to do the heat maps, but we're going to use the MapQuest API instead, which is free. This is the API that we'll be using in class. And you can see they have the option to do a heat map here as well. What you can see is that there's a bunch of HTML in here, and you're going to print all that HTML out. But if we scroll over, it's using this address point to add these latitudes and longitudes to the map. So where are those data points coming from? They're actually imported here from a JavaScript file. So if we just copy that and take a look, you can see that there's a big list of latitudes, longitudes, and then numbers in here. You're going to have to investigate the API documentation to see what that is. But you essentially are going to create a JavaScript file that has those latitudes and longitudes. You'll replace the script here. So instead of loading up their data points, you will load up yours, and they'll be formatted in the right way. And then the heat map is going to use those with the JavaScript in here to create this image. So what you're going to do with this is essentially have this HTML file, but you're going to have it for the source, instead of pointing to this file online, it's going to point to the file that you create. And that file is going to be generated to look exactly like this, be called address points, and have your data there instead of the data that they've created. So what you'll turn in for part 3 is basically a Python file that you can run by typing Python space the file name, same naming conventions as the other parts. That should open that lat long file from part 2. And again, don't put any paths or anything in there, just open the file by its name. And then you should create 2 output files. One is your last name underscore first name.html. That's going to basically have just the HTML from the MapQuest site here with your key in it instead of the sample key. And you also should output last name first name.js that has the coordinates in it. That is going to be this file that you've created to replace the sample file in the MapQuest example. So those things should get output. So basically I can open last name underscore first name.html. That will point to your JavaScript file and I can see your heat map. And then finally, presentations. Now we're obviously an online class, so we're meeting online. What I want you to do instead of what would be an in-class presentation is to make a video. 3 to 5 minutes. You can use whatever you want for that. You can record yourself on your phone. There's lots of great free applications that you can use to record your screen, like I've done for all these videos. If you're really having trouble finding something, let me know and I'll point you to some suggestions, but there's lots of options, including some provided by Terpware. So if you can't find any free ones that you like, take a look at Terpware because there's some video making programs there. So 3 to 5 minutes. You can pick a topic, but I want you to basically create some sort of interesting presentation for me based on the data in the database. So it doesn't necessarily have to be based on this heat map, but based on stuff that you found in that database that you kind of understood by analyzing that data. So it could be something like a location where there's high UFO activity, and then tell me why that is. Essentially, I want you to connect some deeper analysis to the data that you're displaying. So maybe there's a hot spot like in the middle of nowhere on your heat map and you don't know why that is. So you could use that as the motivation for your presentation and then dig in, and maybe it's because there was one incident in that place that lots of people saw. Maybe it's that there's lots of incidents that happen over time in that place. But dig into it and explain why. It doesn't have to be the highest one, but it could just be, an interesting place where you wouldn't expect a lot of activity, and there is. So that's an option. You could do something like a specific UFO sighting incident from the database. So what you'll find in there is that there's plenty of just one-off reports from, frankly, like some crazy dude who thinks he saw a UFO and he puts it in the database and it's just him. And then there's other incidents where there's lots of reports from lots of people about the same thing. It's likely that you'll be able to find those if you look at months or locations that have an abnormally high number of reports, especially if you look at a month. They tend to be a few hundred, and if there's way more than normal, you might jump into that month because that could be an instance of a bunch of people reporting the same event. Tell us what that event was. Why do you think that there's like this one particular sighting? Why did so many people see it? What was the explanation? So for a lot of things, for example, the Phoenix lights are one like very famous UFO example, probably in the video at the top of this presentation. Lots of people saw it. There's full documentaries on it. It's been fully explained by the Air Force as flares that were being tested. There's very convincing videos of that showing it working. Make sure you follow up with like the actual science debunking if there is a real answer to this, which there is for a lot of stuff. That's not in the database, but that's part of your analysis of connecting insights from the database to other information. You may want to focus on a particular class or type of sighting. So we were just looking at the month data, but if we click through to the database, you can see, for example, that there's like the shape of UFO. Here's all the different kinds of shapes. So there's a lot of weird ones. There's just a plain light, diamond-shaped, fireballs. You could pick one of those particular shapes or types of things as something to investigate. And so if we come back down here, tell us what that is. What are the theories behind that shape? So if there's, for example, there's an egg shape. What does that mean? Like, what's the theory behind what these egg-shaped things are? What do they end up being when they're debunked? Is there other information around it? Essentially, what I want you to do here is not just tell me the database says X, but to say this is a thing in the database, and I've done some additional research and analysis, and here's why we're seeing that. So here's the actual event that happened, maybe footage from it. Here's what explains what happened. Here's Area 51. People go out there looking for UFOs, so there's lots of reports from that. Here's a little bit of background on why people are looking there. Here's this particular type of UFO. Here's the history behind that. Here's what it probably is, why people think that. So give me some why to go with the data. If there's another kind of UFO related topic that you're interested in that kind of you can see some information about it in the database, and then you also can find some other information to do analysis on, that's probably fine with me. Just let me know so I can make sure you're going to fulfill my expectations for the assignment. What I don't want is for you to like dive into something without checking with me and then be missing a big component of what this presentation part is supposed to do. So, and I just want to put a little caveat in here. I'm not trying to convince any of you to believe that aliens are visiting us. I think there are probably like life forms other places in the universe. I don't think there's extraterrestrials visiting us on Earth. This is not like UFO propaganda class. But I think this is more interesting than working with like some of the boring real data. You know, I could have you do this same project on the turnstile data that we looked at. I could have you do this with like the Enron email data set. I think it's a little bit more fun to do it with UFOs because there's like great videos and visuals and like interesting conspiracy theories and stuff online. So I think it's just a little more playful. But the idea here is that you're now doing like a real data analysis and representation with this process. You're finding semi-structured data online, you're writing a scraper for it, you're parsing it, you're integrating it into files that you output into other applications like the heat maps. You're then connecting those insights with other analysis that you've done. So you're really doing an interesting data science project with this. And the project is to give you practice with that. So it's not really a UFO project, it's a data science project. And I think this is just a fun way to do it. So don't freak out that I'm like trying to convince you to believe in extraterrestrial visits. I'm not. You're welcome to believe in them or not. But the purpose of this is just that I think this is a fun database, interesting to work with, and it meets a lot of our purposes. For this presentation, I'm going to grade you on how interesting your presentation is. We all have had to sit through many, many boring student presentations. I have been teaching for a long time and have really lost count of how many terrible student presentations I've sat through. Since I started grading student presentations essentially entirely on how entertaining they are, everyone's life has gotten much better. So there's no particular piece of information I'm looking for in here other than you've got something from this database that you've connected to some additional external analysis that you've done. I need to be entertained and it has to have that content, and that's it. If it's boring, you're going to lose points. So make it entertaining. You can include whatever you want. These are, your videos for class. You don't have to post them online. You can just, you're going to give them to me online, but you don't have to post them on YouTube or anything. So steal video clips and photos and reports from other places. Like, that's fine. Just make sure you cite your sources. Don't just show me a 5-minute video that somebody else made, though, right? You're welcome to borrow clips from other places, but write your own narration. Really, make me a coherent presentation. What you're going to turn in for this is your video. You can post it on YouTube or Vimeo, wherever you want, or you can just like upload it directly in Canvas. There's also a discussion board thread where I want you to post that so you can kind of see each other's presentation, since we're not having a class meeting where you're going to present this. You've got a couple weeks to do this presentation as well. So the deadlines I've broken out into their own sections, and we'll take a look at that in a minute. Grading is really simple. Each of the 4 parts is 25% of your final grade. So let's come back up to the assignments. Okay, and we'll just take a look. So you can see we've got final part 1, 2, 3, and 4. So we were just looking at the final overview. That's everything together. There's nothing to submit for that. I've broken out each of the parts into their own separate assignment that has a place where you can upload your content. You can see each one of them is worth 25 points. The due dates are all here, so you've got a couple weeks for part 1, you have 1 week for part 2, a couple weeks for part 3, and a couple weeks for part 4. This is the very last day of the semester, so I've given you all the way to the end. There's not a final exam for this class, so once you turn in that final presentation, you're done. Yeah, so there you go. That's the final. Hopefully it will be fun, interesting, exciting. And like I said, for the parts like using the APIs, which you haven't covered yet, you need those for weeks 2 and 3. We're going to start with those in the next week of class. So you'll have plenty of experience, and I'm going to be doing stuff very close to the examples that you need for class in there. So that's the final. Email with any questions, but give it a careful read because there's a ton of detail that I sort of skimmed over that is available in these documents.